This video is for lesson 16-1, proving a quadrilateral is a parallelogram. It's closely connected to our last activity where we looked at different types of quadrilaterals like rectangles, kites, and so on. One of those was a parallelogram. So back in that previous lesson, we looked at the definition of a parallelogram, a four-sided shape that has two pairs of parallel sides. That is, that the opposite sides are parallel. So if we wanted to show that a four-sided shape was a parallelogram, one way to do that would be to apply that definition to check to see if both pairs of opposite sides are parallel. And if they are, then we could conclude that the quadrilateral is a parallelogram. For example, in this first question, if we wanted to know if this drawing with these ordered pairs as the corners was a parallelogram, we could check to see if the opposite sides were parallel by looking at the slopes. So the bottom and the top are both horizontal. They both have a slope of 0 because they have the same slope. Those are parallel. Then we could check the left side and the right side to see if they have the same slope. It appears to rise 5 units and run 2 units. So the slope of that is 5/2. Now over here on the right, it rises 5 and runs 2, and so that slope is also 5/2. This is a parallelogram because both pairs of opposite sides are parallel. We used the definition of parallelogram to conclude that it was a parallelogram. But there are more ways to conclude that a four-sided shape is a parallelogram because there were theorems that we developed about parallelograms. For example, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Here is another way to tell if a four-sided shape is a parallelogram by applying this theorem. Here's another theorem that can be used to tell if a four-sided shape is a parallelogram. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So all of these theorems give us techniques that we can use to figure out if a four-sided shape is a parallelogram. Here's yet another way. Theorem: if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we've discussed some theorems that can be used to tell if four-sided shapes are parallelograms. Here's some check your understanding questions. Number 9, explain why showing that only one pair of opposite sides of a quadrilateral are parallel is not sufficient for proving that it is a parallelogram. That might look something like this. Let's say that we had a four-sided shape and that the top and bottom are parallel. I'm going to indicate that with these matching arrow symbols. But that this side here and this side here are not parallel to each other. So we have one pair of opposite sides parallel, but the shape is certainly not a parallelogram. And so a drawing like this might be our justification for problem 9. Now problem 10. 3 of the interior angle measures of a quadrilateral are 48 degrees, 130, and 48 degrees. Is the quadrilateral a parallelogram? Explain. To answer this question, we use a theorem that we discovered earlier about quadrilaterals. The 4 angles in every quadrilateral sum to 360 degrees. So if these 3 angles are in a quadrilateral, we could add them together to see what they sum to. 48 plus 130 plus 48 is 224 degrees. 360 minus 224 is 136 degrees. If this figure was a parallelogram, then the opposite angles must be congruent. And if the angles are 48, 130, and 48, then opposite from the 130 must be another 130-degree angle, not a 136-degree angle. So these four measurements don't work out. Is this a parallelogram? And the answer is no. We were able to answer that question because of theorems or properties that we had discovered about parallelograms. So in this lesson, we developed criteria for showing that a quadrilateral is a parallelogram. Those criteria were called theorems, and we had a few of them. One of the theorems that we looked at is that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Another way to tell if a four-sided shape is a parallelogram was this theorem. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. And our third theorem, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Any of these three theorems can be used to tell if a four-sided shape qualifies as a parallelogram.